with those who have joined. Okay, so in last class, we discussed the three main components, and the fourth was slightly discussed. It was left, like a detailed discussion of this fully connected layer was left. So let us first discuss, and let me also revise a few concepts related to our previous three components. Okay, if you remember, we discussed that this convolutional neural network consists of main four components: convolutional layer, activation layer, pooling layer, and fully connected layer. And we discussed what is convolution operation. So if you remember, we discussed that instead of having like many number of inputs in your input layer, using this, you can reduce the number of input neurons in input layer, because we are using a kernel, and that kernel sifts over your image. So we also discussed stride and padding, and how can you determine the size of output. That was also discussed. Okay. And then we discussed, after that, we discussed the activation layer. It is an activation function. So the output which you get from the convolutional layer, it is passed through this activation layer. And from the output which you receive from activation layer, it is passed through pooling layer. We also discussed that we have two kinds of pooling functions: max pooling and average pooling. And we also discussed the advantages of max pooling over average pooling, because it is more beneficial to use max pooling. But sometimes, depending on application, we also use average pooling. Okay. So we discussed this. Okay. And then at last, we discussed pooling layer. So if you remember, we discussed that what it does, pooling layer. It also further reduces the size of image. It downsamples your image. And if you remember, we discussed that, like, you can see in this figure, the original image of bird. And after subsampling, the image is reduced in size, but the features are still preserved, right? So there won't be any loss of information when image is passed through this pooling layer. Okay. So similar to this convolutional layer, pooling layer is responsible for reducing the spatial size of the convolved feature. And this is to decrease the computational power required to process high resolution images through dimensionality reduction. So that is the advantage of using this pooling layer. Fine. Now let us discuss the fully connected layer. Okay, so we discussed that here you have several blocks of convolution plus pooling layer. So this is the like first block where you have one convolutional layer and mix pooling layer. Then you have next block where you have another convolutional layer and pooling layer, and so on. So once after you have certain number of these blocks, you have one fully connected layer in convolutional neural network. Now, adding a fully connected layer is usually inexpensive way of learning non-linear combinations of high-level features as represented by the output of the convolutional layer. So fully connected layer is learning possibly non-linear function in that space. So till this point, till this point, okay, till this point, we have converted our input image into a suitable form for multi-layer perceptron. And after that, now we shall flatten the image into a column vector. Please remember this. Please understand this. Okay, now what we are doing, we have metrics. Okay, if you have seen like the output of the last pooling layer, maybe like this. It will be some matrix. Okay, so it is a feature matrix, feature map we call it. So it's a feature map. Okay. Now what we do, now we flatten it. So how we flatten it? So we convert it into one column vector. So that matrix is converted, that feature map is converted into a vector. I hope you understand this, right? These are the terms related to mathematics. Matrix matlab two-dimensional, vector matlab one-dimensional, cube means three-dimensional. So you can have higher dimensions in space. But now at this point, after the last pooling layer, what we do, we flatten the image into column vector. And this flattened output is then fed to feed forward neural network. Why we flatten it? Can anyone let me know why we flatten it? We have fully connected layer, we have feed forward neural network as the last layer. Okay, so output of that max pooling layer, the last max pooling layer of the last block, that is fed as input to fully connected layer. Okay, so why do we need to convert this matrix into vector? Any answer? You can unmute and you can let me know, or you can type message. जो भी आपको समझ में आया है आप मुझे बता सकते हो. इट्स ओके इवन इफ द आंसर इज रॉन्ग, डोंट वरी. कोई भी कोई गेस, एनी गेस, व्हाई वी फ्लैटन इट and we convert that matrix into vector? Because now we have to feed it to this fully connected layer. Now you can see that the fully connected layer, it has neurons like this in line, right? So if it is a matrix, it won't be easy to feed that those values to neurons, that which value of matrix should be fed to which neuron. But if it is a vector, then it's very easy. The first value in the vector will be fed as input to first neuron, next will be fed as input to next neuron, and so on. So after converting, like for example, the output from the size of matrix from last max pooling layer is 5 cross 5. So that means 25 values are there. Now this 5 cross 5 matrix is converted into a vector. It's not necessary that it is 5 cross 5, right? The dimension may be different. So, but whatsoever it is converted into a vector. So in vector, you will have all those value as a list of elements. Okay, and those many, like number of elements, uh, uh, we will have number of neurons in input layer equal to number of elements in that vector. So as now we flatten that input, we flatten that output from last pooling layer and we convert it into a vector. And this flattened output is then fed to a feed forward neural network. And then after we feed it to feed forward neural network, back propagation is applied to every iteration of training. ये जब हम यहाँ से यहाँ तक जाते हैं fully connected, देखो ये पूरा CNN का architecture मैंने दिखाया है. Though I am discussing only fully connected layer, right? So that architecture is expand. अगर आपको याद है तो ये architecture में भी मैंने दिखाया था. यहाँ पे देखो आप. This is flattened. This output is now flattened, then it is fed to fully connected layer. And here we have softmax classifier. Okay. तो ये जो सारा है यहाँ पे, this is for classification और ये आगे का architecture. So ये पूरा part convolutional neural network बनाता है, right? So now here you can see that I have shown you the full architecture of convolutional neural network. Okay, so you can see that this is one input image. Okay, now please be with me. I'll tell you. अगर आपको याद है, we discussed that MNIST data set जिसमें character images है और वो images black and white है और उनका size मैंने क्या बताया था 28 cross 28 cross 1. So this is a sample image from that MNIST data set. Okay, ये क्यों है? I tell you now. These images are of numbers. Which numbers? 0 to 9. These images in MNIST dataset are of numbers 0 to 9. Okay. So what we do, MNIST dataset में जितने भी records है, जितनी भी images है, we train this convolutional neural network. Why do we train this convolutional neural network? Because we want to make character recognition automated. We want to automate character recognition. अगर आपको मैं image दिखाऊं तो every one of you knows that this is number 2 because you have learned it. Your biological neural network has learned that. So you can recognize this character as 2. अगर यहाँ 2 की जगह देखो, it is not written in exact like अच्छे handwriting में, it's not written in good handwriting. But then too you can guess it because you have good learning of character 2. So you can recognize that this is 2, though it is not written in good handwriting, right? Because your learning is good. Okay, so similarly, if I want machine, if I want computer to recognize numbers, character recognition, right? If I want to automate character recognition, then I want to train this convolutional neural network with different numbers. Okay, and that MNIST dataset includes images of numbers. So using those images, we can train convolutional neural network to identify, to recognize this different numbers, right? So once we train it, once it gets trained with all those images, we can deploy it for real life application. After testing, like it's not directly we use it, we train it, we test it, and then if its performance is if we get if we find if we find its performance reasonable, then we deploy it. Okay, so when we deploy it, now it is automated. Now you just feed it, now you feed a new image, it will recognize, okay, this is number 5, this is number 2, this is number 0. Okay, it will recognize once it is trained. So now to train it, what we do, okay, here I would like to discuss two points related to training. The first point, this MNIST data set has certain number of records. Let's assume, I don't remember exactly how many records are there in MNIST data set. Let us assume there are 5,000 images. Let us assume that in this MNIST data set, 5,000 images of characters are there. Now, I don't know how many images are of zeros, how many images are of 1. Let us again assume that among this 5,000, there are equal number of images for character 0, for character 1, for character 2, and so on. Equal number of. Okay. So now this CNN will be trained with these numbers. अगर 5,000 की जगह 500 images होती, let us assume that there are not 5,000 but 500 images. So will it be any disadvantage in training the CNN or automating this character recognition? Can anyone let me know? जो भी आपको समझ में आ रहा हो, उससे आप मुझे बता सकते हो. अगर 5,000 की जगह 500 images ही है डेटा सेट में, जिससे मैं CNN को ट्रेन कर रही हूँ. So क्या नुकसान है उसमें? Is there any disadvantage if we have less number of images? What is the disadvantage? Yeah, that is true. Yeah, that is true that model will get to learn less. Any other answer? अच्छा, लर्निंग लेस होगा तो क्या होगा? Okay, output won't be precise. That is also true. Aditya, right answer. Yes, output will not be precise. अगर आपने अच्छे से कुछ चीज लर्न नहीं की है, suppose I teach you only twice. I teach you only twice कि this is number 2. ओके जब आप छोटे थे, जब आपने लर्न किया कि विच इज नंबर 1, विच इज नंबर 2, विच इज नंबर 3, लेट अस assume that the kids are taught only twice that this is number 1, this is number 2. Will they be able to recognize these numbers? No, they won't be. अगर मैं उनको, चलो पहले तो मैंने सिर्फ 2 बार टीच किया तो वो नहीं शायद याद रख सकते, बिकॉज सबका लर्निंग रेट अलग रहता है. सो दे मे नॉट बी एबल टू recognize numbers correctly if I teach them only twice. ठीक है. If I teach kids in class 5 times that this is number 1, this is, comparatively their accuracy of recognizing characters will be more comparatively. I hope you agree with me. Okay, they'll be able to, instead of 5, now if I train them 10 times, so maybe it's still like more, right? Okay, now be with me. Okay, मैंने क्या कहा पहले, मैं 2 बार टीच कर रही हूँ. Maybe out of 10 students only 2 could remember that this is number 1, this is 2, and so on. जब मैं 5 बार सिखा रही हूँ तो out of 10 let us assume that 4 students can recognize. जब मैं 10 times सिखा रही हूँ, maybe out of 10 let's say 8 students, like have been able to recognize those characters correctly, because मैंने 10 बार सिखाया कि this is 1, this is 2 and so on, 10 बार सिखाया, तो 10 में से कितने स्टूडेंट्स एक्यूरेटली डिटेक्ट कर रहे हैं सारे कैरेक्टर्स? 8. Okay, now let us assume I am again giving them training of this numbers and मैंने 12-15 बार सिखाया. Maybe now all are able to recognize those numbers correctly. अब 12, now when I'm teaching them 12 times or 15 times, and then when they all have been able to recognize those numbers correctly, do we need to train them again for these numbers? No, because वो train हो चुके हैं. अब उनको ओवर ट्रेनिंग नहीं देना है, राइट? ओवर ट्रेनिंग नहीं देना है, वे कैसे पता चलेगा? Because हमें कैसे पता चलेगा कि out of 10 only 2 students have learned to recognize those characters correctly? Because after teaching them twice, I may check, I may ask them, which is this number, which is that number, and I check whether they are able to. So we evaluate, we take test, we take exam, and we come to know that they are not able to recognize correctly. So we train them again. So similarly, when we train any model, machine learning model or deep learning model, once we train it, we check the error. Okay, हम वो error measures है, we measure the error. If error measure is not 0, that means like अभी भी उसको सही से training नहीं मिली है. So we train it again until that our goal is to minimize that error. Ideally it should be 0, but कभी-कभी 0 नहीं भी होता है. ठीक है, नहीं भी होता है, तो हम जिस लेवल पे वो कांस्टेंट हो जाती है, वे स्टॉप ट्रेनिंग. सो यहाँ पे भी हमें, अभी मान लो मैं 15 बार सिखा रही हूँ, देन टू ओनली 8 स्टूडेंट्स हैव लर्न एंड 2 स्टूडेंट्स आर नॉट एबल टू स्टिल रिकॉग्नाइज. 20 टाइम्स आई एम ट्रेनिंग, बट स्टिल दोस 2 स्टूडेंट्स आर नॉट एबल टू रिकॉग्नाइज नंबर्स, right? So in that case, what I can do, I cannot train train again and again. Then I should understand that those 2 students may not be able to recognize some characters accurately, right? There may be some other problem. Okay, and then I should stop training because I'm not able to improve the accuracy. कि वो 2 students correctly recognize कर पाए, उसके लिए मैं कुछ नहीं कर पा रही हूँ. So then I should stop training. Okay, so one thing like number of iterations. We do not train any machine learning or deep learning model through only one go. हम जो भी images रहती है, MNIST data set है या or if it is some other data set, what we do, we train this neural network multiple times, right? And we stop after certain iterations. So there are some criteria to stop the iterations. Second thing, मैंने पूछा था कि 500 images हो तो क्या? If there are not 5,000 and if 500 less data, उसमें मैं एक और example same let us extend the discussion of the same example. Now I'm teaching you again and again, but I am a teacher. Okay, I have a particular handwriting and I am teaching you that 2 is written like this, 1 is written like this, and so on, right? Tomorrow, some other teacher having not good handwriting will write and will test you that which is this number. You may not be able to identify certain numbers because उनकी handwriting पूरी अलग है. जो मैंने सिखाया है मेरी handwriting से, मेरी handwriting neat and clean है. And I have been able to teach you clearly that what is number 1, what is number 2, what is number 3, and so on, right? And tomorrow, one day when I am absent, right, some other teacher comes and asks you that which is this number, but teacher is not having good handwriting, right? And may ask you that which is this number. Some of you may not be able to identify some of the numbers correctly. So what does it mean? That because only you got trained with handwriting of only one teacher. But this MNIST data set, it includes images of numbers in different handwriting so that we can train model with variety of handwritings. So that's why sometimes we should have sufficiently large data set and we should have data set having different types of different types of data set should have maximum number of possible cases. Like ऐसे भी 2 लिखा जाता है, ऐसे भी 2 लिखा जाता है. जितना अच्छा आप उसको different styles में training दोगे, उतना अच्छा वो learn करेगा और उतना अच्छा उसका accuracy बढ़ेगा. Right? So I hope you are getting my point. These 2 things are very important. Like accurate training के लिए, when we say ना that model is able to give good accuracy or good prediction or good classification or not. It depends on so many parameters. These are not only two parameters. एक तो कितना ट्रेनिंग दिया आपने, डेटा सेट कैसा है, डेटा सेट में जो डेटा है, व्हाट इज द क्वालिटी ऑफ डेटा, व्हाट इज द साइज ऑफ द डेटा, व्हाट आर द डिफरेंट टाइप्स ऑफ केसेस अवेलेबल इन डेटा. So what are the hyperparameters you have used to train the data? So many, like what is the size of data set? So many parameters are responsible for training of the network, and like accuracy depends on all these parameters. It doesn't depend on a single parameter. Ki if you have sufficiently large data set, then we will be able to train it accurately. No, not like that, right? So always like automating tasks using this machine learning and deep learning models involves exhaustive experimentation. It involves exhaustive experimentation. Once you choose the model, you train it with the data set, and then you have to test with considering different real-time scenarios. Okay, so that's why like multiple iterations and all are done. Okay, so we were discussing this. Kush wrote that there are chances that underfit problem. Yeah, that is also true. Okay, so we were discussing this, and I at last I think I told you that after flattening this image into a column vector, when you feed it to feed forward neural network, and then you have to apply the back propagation in every iteration of training. So just to explain you why every iteration of training, because there are several epochs, there are several iterations of training, because we cannot train network in one iteration. So multiple iterations will be there, but there is no standard number that, okay, we can train every network in, or we can network particular network in 100 epochs or 100 iterations or 50. No, not like that. It depends on so many things, and we have to experiment it. So over a series of iterations, the model is able to distinguish between dominating and certain low-level features in images. Yeah, one more reason that why we are training again and again, so that it will be able to, जैसे आपको भी कोई चीज की मतलब बार बार ट्रेनिंग दी जाए, then you become expert ना, कि ओके ऐसे होता है तो ये 2 नंबर, ऐसे होता है तो 6 है, और ऐसे होता है तो 9 है. Matlab initially, and that this is fact, when kids initially learn these numbers, they sometimes get confused that which is 9 and which is 6, because they have particular, not all kids, maybe few, but some kids, they get confused in 6 and 9. So, but when you get trained again and again, you come to know, okay, 6 में नीचे होता है round, 9 में ऊपर होता है. So that way, like they learn some features. Okay. So over a series of iteration, the model is able to distinguish between dominating and certain low level, like high level and low level features in image, and classify them using the softmax classification technique. Okay. So like thus we can say that fully connected layer is a traditional multi-layer perceptron structure, and its input is a one-dimensional vector that represents the output of the previous layers. Okay, output of the previous layers. Its output is a list of, okay, now what is the output of this fully connected layer? हमने अभी तक बात कर ली कि पहले कौन से ब्लॉक्स है, ब्लॉक्स कंप्राइजेस कॉन्वोल्यूशनल एंड मैक्स पुलिंग. ओके, ये जो ब्लॉक्स है मतलब ये मल्टीपल है, एंड लास्ट में जो मैक्स पुलिंग लेयर है उससे जो आउटपुट आएगा वो है मैट्रिक्स, दैट इज कन्वर्टेड इनटू वेक्टर. वेक्टर इज फेड टू फुल्ली कनेक्टेड लेयर. ओके, नाउ फुल्ली कनेक्टेड लेयर से हमें क्या आउटपुट मिलेगा? प्रोबेबिलिटीज, इफ इट इज अ क्लासिफिकेशन प्रॉब्लम. हम यही एग्जांपल की बात कर रहे हैं, बिकॉज नाउ व्हेन वी फिट दिस वी वांट टू नो whether it belongs to how many classes are there. You can see the classes indicated by red color circles. 10 classes are there, 0, 1, 2 up to 9. 10 classes are there. So we have fed this input, we have fed image of number 2, and we want network to know that this image is of which class. So it is of third class, which is number 2. Okay, so what will be the output of this feed forward neural network? The output will be probability for different possible labels attached to this image. So for example, if it is a animal classification, ये हमने discuss कर लिया. Let us discuss now similar example. Okay, यहाँ पे हम numbers को classify कर रहे हैं. Now suppose we want to classify animal. So if it is animal classification problem, then labels may be like horse, zebra, dog, etc. Fine. So if it is similarly, you may also have vehicle classification problem. कोई भी classification problem हो सकता है. Disease classification problem. तो अगर जिस तरह से आपका इनपुट है, जिस तरह से आपका प्रॉब्लम है, डेटा सेट है, अकॉर्डिंगली यू विल हैव नंबर ऑफ क्लासेस, राइट? फॉर एग्जांपल, माय डेटा सेट comprises of three kinds of images of three types of animals: horse, zebra, and dog. Then I may have three classes. Okay, and when you feed this image to this convolutional neural network, it learns features, and finally यहाँ पे probability आएगी like this कि what is the probability that this image is of horse, what is the probability that this image is of zebra, and what is the probability that this image is of dog. So you can see the probability 0.2, 0.7, 0.1. So like as we know, the summation should be 1. Right, so this is our softmax activation function. It is softmax classifier. So based on this probability, now it is classified into one of these three classes. The probability of this image is of zebra is higher. So this image will go to which class? Zebra. Okay, so you can see that this tags given at the bottom line. This is this part of this convolutional neural network is responsible for feature extraction. After that, this fully connected layer, it is responsible for classification, and softmax activation function, it is responsible for probabilistic distribution, so that we get the correct classification, right? So this is how this convolutional neural network works. I hope this is clear. If you have any doubt till this point, we can discuss. If you have any question till this point. Clear, everyone? You may write your answer in chat box. Yes, no, not clear. Then I may repeat. ये आपको अच्छे से understand करना है. Okay, thank you, Viraj and Shruti. Okay, I hope others are with me, though their answers are not there. Fine. Okay, thank you, Jenish. Okay, so I assume it is clear because there is no question. Okay, so we have discussed the 4 layers of convolutional neural network. So how it looks like the full CNN. We have discussed it, but again, there may be, like as I discussed, there may be multiple convolution and pooling layers depending on the CNN architecture. So you can see that one convolution, one max pooling, and you will get new image, but its size is reduced. जो आपने input दिया है उससे इसकी size कम होगी. So this is dimension of that image is reduced. And so we say that this image is smaller than the original image. Then we have next block of convolution and max pooling. Again, we will get like this is repeated. These blocks are repeated and we will get another image, which is further reduced in size. So such we have several such blocks. And then after having such blocks, we flatten the feature map of this image. And then finally it is fed to fully connected feed forward network. And then we get classification. So this is how the whole CNN looks like. Okay. Fine. So that was all about the architecture of convolutional neural network. Now let us discuss about the training of this convolutional neural network. That how should we train it? Okay. CNN can be trained either like CNN model is trained uh, with like two parts of the given data set, training data set and testing. Okay, so training is carried out by model is created. The model is like made ready via training and testing. So now for training, there are two options. Training a CNN from scratch. आपने एक architecture बनाया. You may have created shallow CNN or you may have created deep CNN, depending on the complexity of the data in your data set. And now you want to train your CNN. Okay, so you may train it from scratch, or as you can see here, you can use the pre-trained CNN. Pre-trained CNN, already trained CNN hai, right? So you may create a new architecture for CNN and you can train it from scratch, or you can use pre-trained CNN for feature extraction, right? I'll tell you how this pre-trained CNN works, but it is called like transfer learning. And after, whether you train it from scratch or whether you train it for using pre-trained CNN, after that testing is carried out, and that is use train model on test data. Okay, so I'll tell you that why pre-trained CNN are sometimes more beneficial than training CNN from scratch. Okay, now training CNN from scratch, it requires a massive amount of labeled data. It requires massive amount of labeled data. Okay, हाँ वापस एक बार याद कर लो, हमने सेकेंड यूनिट में लर्न किया था डिफरेंट डीप लर्निंग different deep neural network architectures. And that time we discussed that we have some supervised learning models and we have some unsupervised learning models. So supervised learning model में CNN fall होता है. So if CNN is supervised learning model, then it requires labeled data, right? Because supervised learning means we use labeled data. Unsupervised learning means we use unlabeled data. So CNN is supervised learning model and we need labeled data, but the CNN requires a massive amount of data, labeled data, if we want to train it from scratch. Now, massive amount of data is required to make the CNN learn features well, so that it can learn features well and it can generalize on the test data. Moreover, training a CNN from scratch, it requires initialization of hyperparameter such as nonlinearity, pooling, optimization algorithm, regularization parameters, bias, and so on. Weights are also calculated in feed-forward manner and transferred till end. If you train your CNN from scratch, what is required? I'm telling you what is required if you train it from scratch. One, you need to initialize hyperparameters such as pooling, like you need to choose pooling operation, optimization algorithm, regularization parameters, and so on. Two, weights are calculated in feed-forward manner and they are transferred till end. Three, you have to choose a loss function and you have to calculate it during training. Four, this process is repeated, updating parameters till accuracy, like desired accuracy is achieved, right? So these are the things which happen when you train from the scratch. However, for many applications where data is not available in sufficient quantity, data is not available, like data is less, the training a neural network from scratch can lead to overfitting because we have less data. Because network will not be able to generalize well when we have less data, and overfitting may occur. And overfitting means we know that network is not able to learn effectively and prediction accuracy would be low when overfitting occurs. So this is the problem when you train your neural network from scratch. Now to overcome this, like several pre-trained CNN models are available, which have been trained on millions of images using GPU. They have been trained. Moreover, if you want to train your neural network from scratch using massive amount of data, maybe you may not be able to train that CNN using your normal desktop or laptop machine. you may need GPU, which is called graphical processing unit. So only CPU may not be sufficient to train your model with massive amount of complex data like images and all. So you may need GPU or you may need TPU. So we can use these models, like we can use these pre-trained models to extract the features related to your application, and then you can fine tune it. You can fine tune that pre-trained model for the classes which your application requires. So these are the, like, I'll show you the models which can be used, which are the pre-trained CNN models, which can be used for your applications. I hope the need of pre-trained CNN is clear. That why should we use pre-trained CNN? What is the need for pre-trained CNN? Okay. In several applications, domains, like as I told you, large amount of data is not available. Large applications like, for example, uh, disease detection. There are several rare focused or disease available which are not explored for automated disease diagnosis. So, like काम कर रहे हो, you want to automate disease diagnosis, and you doctors, and you may request for data. Okay. Now, when you consult doctor, doctor may or may not have data to give you, because there is no need for them to keep that data with them. आज जो भी चीज है, मान लो आप गए और किसी को कोई एक चिकन पॉक्स है या मीजल्स है या रूबेला है या फिर डेंगू है, all these diseases, type of like uh, rash based diseases, चिकन कहते हैं, होते हैं, डेंगू में भी रेड रैशेस होते हैं, राइट? Only difference feature automated systems should be able to diagnose that disease, कि whether it is chickenpox, whether it is rubella, whether it is measles or whether it is dengue. Right? ऐसे आप एक system बनाना चाहते हो. Now, when you want to make such a system, when you want to automate the diagnosis of these diseases, what you have to do, you have to train your machine learning model or deep learning model. Now, to train this model, आपको कैसी images चाहिए? जिन patients को past में measles थे, जिन patients को past में chicken pox थे, जिन patients को past में dengue थे, उनके skin के pictures चाहिए आपको, जो उनको rhesus हुए हैं, so that you can fit these cases to your maybe your CNN. CNN will learn and be able to diagnose these diseases. So for these images, for such images of patients, you may consult doctor. आप doctors के पास जा रहे हो, right? Now, what was the reason? There was no reason with for them to collect the pictures of such patients. तो उनके पास है ही नहीं. तो diseases बहुत सारे हैं आज के रेट में, लेकिन उनको ऑटोमेट करने के लिए जो डेटा चाहिए ना, डेटा इज नॉट अवेलेबल. Okay, now you may request some physicians or doctors to collect data because आपको ऐसे automate करना है. So what they'll do, they may collect data over the next 6 months, over the next 1 year. लेकिन वो आपने क्या किया, आपने एक डॉक्टर को कंसल्ट किया या अपने रीजन के 4-5 डॉक्टर्स को कंसल्ट किया, and they may collect data and they may provide you so that you can train your neural network. But वो data sufficient नहीं होता है, बिकॉज वो वही रीजियन के डॉक्टर से आपने कंसल्ट किया है. सो दे आर स्पेसिफिक, लाइक दैट पॉपुलेशन इज ऑफ स्पेसिफिक टाइप. तो वो पॉपुलेशन के हिसाब से आप ट्रेन कर रहे हो, तो योर ट्रेन नेटवर्क विल बी एबल टू डायग्नाइज दिस डिसीजेस of your people of your region only, patients of your region only, right? So it's not easy, and that's why, like in many cases, this is only one sector which I discussed about, healthcare sector. But there are several such real time other sectors wherein we do not have sufficient data for many problems. And when you do not have sufficient data, you cannot automate those tasks. You cannot automate those jobs, and that's why like nowadays, the biggest job is data collection. And when you learn data science subject, you will learn that 70% of time spent by data scientists is on data collection. बाकी के स्टेप के लिए तो सिर्फ 30% टाइम ही चाहिए ऑटोमेट करने के लिए, बट डिफरेंट टाइप्स के डिफरेंट रीजन के डेटा कलेक्ट करने के लिए आपको 70% टाइम, टोटल डेटा साइंस प्रोजेक्ट का जो टाइम रहता है उसमें से 70% टाइम इज इन्वेस्टेड इन डेटा कलेक्शन, बिकॉज देन ओनली यू कैन क्रिएट गुड मॉडल विच विल give you good output, right? So यहाँ पे भी like, okay, now when you do not have less data, what is the other option? Because if you want to collect data, it may take next 1 year, it may take next 2 years. It depends on again the problem domain. अगर कोई ऐसे डिसीज पे फोकस कर रही हूँ जो रेयरली अकर होता है, तो सफिशिएंट डेटा कलेक्ट करने में 3 या 5 साल भी लग जाते हैं. Or if I am focusing on disease which occurs very commonly, for example pneumonia ले लो या फिर और कोई disease ले लो which occurs very commonly. So if you want to collect data for such disease, then you may get data over the next 6 months or next 1 year, sufficient data to train your model. But it again depends on the problem on which you are focusing, that how much time you will need to collect the data. So instead of that, the solution is and extensive in conducting medical image acquisition process. So in such domain, it is not possible to train CNN model from scratch with less amount of data because it leads to overfitting. And so, like moreover, training with a small amount of data makes model memorize the data. अगर आप क्या करते हो, अगर small amount of data से train कर रहे हो, so what the model will do, model will memorize it. आपको अगर मैं 5 ही नंबर्स याद रखने के लिए बोलूं कि यू हैव टू रिमेम्बर 500, 525, यू हैव टू रिमेम्बर 570 एंड 690 एंड 670, 5 नंबर याद रखने, कल याद रख के आना, तो याद रखते हैं आप, क्योंकि 5 ही नंबर दिए मैंने आपको याद रखने के लिए. लेकिन अगर मैं आपको बोलूं कि रिमेम्बर द 1000 नंबर्स, कैन यू रिमेम्बर? नो, you can't remember, right? So when you train like model with less amount of data, you model memorize that data, and it does not generalize well when it memorizes the data. So many applications, like for many application, we use pre-trained CNN to extract the features from input images. So in order to carry out feature extraction process using like, pre-trained CNN models, first we initialize the network parameters. Okay, that I'll tell you later, but let me show you first which are the pre-trained models available. So here you can see some of the pre-trained models. I have not added the latest models. You can see that they are in order 1998 से 2017 तक है. पता नहीं ये पुरानी slide होगी. Actually latest models hai. So this is 2023, so the models of last 5 years are missing in this slide. So every year challenge is organized, और वो challenge में जो models win होते हैं, वो models like there are many models, like these are the models won on the same ImageNet large scale visual recognition challenge in different years. So, so many pre-trained convolutional neural networks are available. Okay. So I maybe now it is more available. One or maximum two hidden layers, but this deep neural networks they can have as many as 201. You can see here the highest number of this hidden layers, 201. So these are the different, these are the different uh, deep neural networks, and these are the number of hidden layers in the कितने यहाँ पे hidden layers है 201 and associated with each hidden layer there are parameters. So if more hidden layers, more parameters, less hidden layers, less parameters, because complexity would be less. You can see that here it is this is 22, so 7.0. एंड दिस इज द इमेज इनपुट साइज. ये जो सारे डीप न्यूरल नेटवर्क्स है उनको ट्रेन करने के लिए जो इमेज डेटा सेट यूज हुआ है उनके साइज क्या है? दिस आर द साइजेस. This this is the different neural networks. Okay. So I think we have a strict retrained object detection, document analysis, and see handwriting and optic character recognition. The analysis or optical character recognition, then we have to train model with different handwriting. So maybe with A to Z alphabets, with all numbers, with all special characters and all. Auto translation, like English to French, Chinese to English, and medical image comparisons, health risk assessments, medical assumptions, right? Doesn't implication. Okay, so like progress. Okay, many questions like usually students have. So like they many times when I conduct class on the CNN, students ask that whether CNN is better than RNN, because these are the two popular models, right? But let me tell you that CNN and RNN, these are two very popular models, deep learning models. But let me tell you that RNN is suitable for temporal data, that is sequential data, and CNN is considered to be more powerful than RNN. RNN includes less feature compatibility when compared to CNN, and this network takes fixed size inputs and generate fixed size output. While convolutional neural networks, they are designed to map image data to output variable, right? So दोनों का input ही अलग है. RNN का है temporal data, which is also called sequential data, while CNN का input क्या है? Images. So CNN, like advantages are also known. What are the advantages of CNN? I hope it is clear to you. Yeah, CNN. Okay, I told you that CNN is used for images, right? And it can be applied to like two-dimensional, three-dimensional images. Okay, and number of layers. Many times students ask that how many layers does CNN have? So how many layers? Like there is no standard of your problem, but yes, there are three types of layers, like convolutional pooling and fully connected. But number of, so there's no answer because well, only solution. Remember, discuss this. When there is no hidden layer, what does it mean? It What is your answer? Whether CNN is supervised or unsupervised learning? Be honest in your answer, okay? या आपको जो भी समझ में आया है आप मुझे बता सकते हो whether it is supervised or unsupervised. Okay, Vraj, Shruti, Dhaval, they have answered. Yeah, it is supervised. Semi can be supervised. Vraj, I'll tell you, it cannot be because semi-supervised means you have semi-supervised means you have CNN. That is different. They are different, machine learning models. For example, that time we can use semi-supervised learning or we can use self-supervised learning if our data set includes some labeled as well as some unlabeled data. Fine. So this is supervised. CNN is supervised learning. What is filter in convolutional neural network? Filter detects special patterns such as ages, like kernel. Okay. And the typical choice for kernel filter is 3 cross 3 or 5 cross 5. The first convolutional layer is often, okay, I forgot to tell you that different convolutional layer in CNN can have different kernel size. So usually first convolutional layer is often kept larger. Its size is less important as there is only one को पता है, padding आपको पता है, striding पता है. So if you have any question related to that, we can discuss. Okay. And so I think it's okay now if we start next time because only 5 minutes are left and like we cannot discuss it partially. We will discuss this use cases in next class. Is that okay?
Okay, ma'am.
Thank you. Thank you so much. So if you have any question, then you may ask or you may leave.